Okay, this is the last video that covers chapter 11. Conduct the following test at the alpha equal 10% level of significance by determining null and alternative. Test the statistic, and if it is a critical value, I'm gonna skip this one because it should be just the p-value approach. So I just put that by mistake, but just to show you how you would run this one. But assume that the question here is to find the p-value, not the critical value. So you would go to stat, tests. You see you have two samples, two proportions. So you choose two proportion z-test and you enter x1, which is 30. See how easy it is when you know how to use technology. 254 and then 36 and then 302. And then what we're testing whether P1 is different from P2. So you select this one, enter, and that's it. So calculate. Z is negative 0.039. So you see, if you round it to 2 decimal places, will be negative 0.04. Let's suppose that C was the p-value. The p-value here is 0.96, and the p-value is more than alpha. Alpha is 10%, so you fail to reject the null hypothesis. Do not reject the null hypothesis. Next. All right. The next one covering section 11.1 as well. In 1941, an organization surveyed 1,100 adults and asked, are you a total abstainer from, or do you on occasion consume alcoholic beverages? Of the 1,100 adults surveyed, 140 indicated that they were total abstainers. In a recent survey, the same question was asked of 1,100 adults and 407 indicated that they were total abstainers. Determine the sample proportion of each sample. The sample proportion, guys, is x over n. So you just take 440 and divide it by 1,100, and then you take 407 and divide it by 1,100. So you get the answers here. So 440 divided by 1,100, you see you get 0.4. That's the first one, and the second one will be 407 divided by 1,100. All right. Has the proportion of adults who totally abstain from alcohol changed? Change means equal, not equal. If it doesn't say increase, decrease, change means different. So you just put the different sign. Now we need to verify that the requirements are met. There are three requirements you have to select. The N1, the sample size N1 times P1 hat, which is the 0.4 times 1 minus 0.4 must be greater than 10. And the second one, N2, which is 1,100 times 0.37 times 1 minus 0.37 must be greater than 10. The samples must be independent. You always select that. And the sample size is less than 5% of the population size. Okay, your null and the alternative will be P1 equals P2 and P1 not equal P2 because he says changed. He didn't mention bigger or smaller. How do you run the test? You go to your calculator. Tests, two proportion z-test. Okay, let's go back to x1 is 440 over 1,100 n1, and this one is 407 1,100, and we're checking if P1 is different from P2 and calculate. And look, guys, here is the Z 1.44 and the p-value is 0.148, which is bigger than alpha. If it is bigger than alpha, you fail to reject the null hypothesis. And you say, when you don't reject the null hypothesis, you say there is not enough evidence to support the claim. There is not sufficient evidence at the 0.01 level of significance to suggest that the proportion of adults who totally abstain has changed. So we don't think it has changed. It's very much still the same. Next. To test the belief that sons are taller than their fathers, students randomly select 13 fathers who have adult male children. She records their height of both the father and son in inches and obtain the following data. Are sons taller than their fathers? Use alpha equals 0.10% level of significance. Note, a normal probability plot and box plot of the data indicate that the differences are approximately normal, distributed with no outliers. Okay, here is how we run this test. This is a very special exercise that comes from section 11.2 when the samples are dependent. You see the father and sons, they're dependent. It is, so the son could take from after the father, so they are called dependent samples. He wants us to test whether the sons are taller than their father. And this is how we go about doing this. So when the samples are dependent, when you have two sets, it says before and after, father and son, they are dependent. This is how you perform the test. He wants us to check if the sons are taller than their fathers. So this is what I did. You subtract the two columns. So I'm doing son minus father, although in the problem he says do father minus son. It doesn't matter. So we do the son minus father, 74.7 minus 69.8, I got 4.9, 76.3 minus 72.8, and so on and so forth. So I got all those information. You do this test against the number 0. If the sons are taller than their fathers, you would expect the difference to be positive. Because if the son, let's say, is 70 inches and the father is 68 inches, so 70 minus 68 is 2, which is positive. So that would be your alternative hypothesis in here. It will be mu d is greater than 0. So we need to check that the mean of the difference is greater than 0. But if you did father minus sons, if the sons are taller than their fathers, then the fathers are shorter. So you want the difference to be negative in this case. But all those problems will be with the numbers will be of opposite signs in this case. And HO will always be mu of d equal to 0. And what you do here, forget about the heights of the fathers and heights of the sons. You're just going to use this data set, which is called the difference. I already input this data set into the calculator. I put it in L1. So we're going to go to stat, tests. It's a t-test. So section 11.2, it's a t-test. Data, we have the data set. It's against 0, always against 0. So you have to put 0 here. My list is L1. And what am I testing? I'm testing that the difference is greater than 0. So enter. And just go ahead, calculate. Enter. So your test statistic is 0.131. Your p-value is big, 0.449, which is bigger than alpha. You fail to reject the null hypothesis, and you conclude that there is not enough evidence that the sons are taller than their father. So my p-value is in what range, guys? It's 0.44, so it is between actually 0.25 and 1, which is huge. So I fail to reject the null hypothesis because the p-value is greater than level. So there is not sufficient evidence to conclude that the sons are taller than what their father. That would solve the problem. Okay. test whether mu1 is less than mu2 at the alpha equals 0.02 level of significance. Okay, it's just straightforward. So we need to use a two sample t-test, and let me show you how to do that. So you go to stat. Since you have two means, we're testing the difference between two means. So tests, this one, guys, enter. I don't have data, I have summary here, so it gives me summary of the data. So what is x1 bar is 103.4. What is S1? 12.2. And N1 from population 1 is 33. Then he says x2 bar is 114.5. S is 13.3. And N2 is 25. And what we're testing, that mu1 is less than mu2. So it's gonna be which one right here, if you guys... So let me just close this one. Okay. That's gonna be the one right here. mu1 is less than mu2. Always equal sign in the null hypothesis. So less than, make sure to select it, press enter. Now, for pooled, keep it as no. Keep it at a no unless if he says population variances are equal. Since he didn't mention that, so it is no by default. And then scroll down, and hit calculate. So t is negative 3.26. You just p-value, you put it here, whatever the p-value is, which is what? 0.001. And what's alpha here? 0.02. This p-value is less than alpha, so we reject HO. And we say there is sufficient evidence to conclude that mu1 is less than mu2. Okay. A researcher wanted to determine if carpeting or uncarpeted room contains more bacteria. The table shows the results for the number of bacteria per cubic foot for both types of rooms. A normal probability plot and box plot indicate that the data are approximately normally distributed with no outliers. Do carpeted rooms have more bacteria than uncarpeted rooms? So more means greater than. And we're gonna carpet here, and definitely mu no carpet. And here will be what? Mu carpet equals. Remember, the null is always the equal sign. Okay. It's a two sample t-test again. How we're gonna go about doing this? You can do it in StatCrunch. If I open this in StatCrunch, and I'll show you how to do that in StatCrunch quickly. So let's see. Okay, so we go to stat. It's T. So mostly T, guys, in this course. T, stats. Not one sample, it's two sample with data. Okay, first one is carpeted. Second one is uncarpeted. And what are we testing? We're testing that the mean of carpeted is more than the mean of uncarpeted. So this is the sign we're gonna select greater than, and that's it. Don't select the pool because he didn't say population variances are equal, so leave it unselected here and just hit compute. And here's the test statistic, guys, 0.775, and this is the p-value, 0.2257. And which is more than alpha, so you fail to reject the null hypothesis. How do you do this on the calculator? This is what you can do. Stat, enter. You enter the carpeted information in L1, and you enter the uncarpeted information in L2, and then you go to stat, tests, two sample t-test. Sorry, I skipped it. It's number 4. You select data. and you make sure that you choose the proper list. Don't change the frequency, and what we're testing, mu1 is bigger than mu2. Enter, and always pooled, leave it as no, and then hit calculate. You're gonna get the same answers. So my p-value is more than alpha, and we don't reject the null hypothesis because the p-value is greater than the level of significance right here. Okay. The data table represents a measure of a variable before and after. Once you see a before and after the same individual, the samples are dependent, so we have to do the difference in this case. Does the sample evidence suggest that the treatment is effective in decreasing the value of the response variable? So we want to see if the measure of a variable before and after a treatment decreases. So if we want to see if there is a decrease after that treatment, use a 5% level of significance. Okay, just like in the previous problem, we said we want to check if the treatment is effective in decreasing the value of the response variable. So we want to see if there is a decrease after using the treatment. So what you do the differences first. 41 minus 37, 43 minus 35, and so on and so forth. You put those differences in L1, as you can see in my calculator. Now, here is what we need to test. You put mu d here, mean of the difference. If there is a decrease, then you would expect the numbers after to be lower than the numbers before. So ask yourself, give a number, let's say 10. If you want the number to be after to be lower, let's say it's 7. 10 minus 7 is 3, which is positive. So you want to make sure that you test mu of d is greater than 0. This is the claim. And that's always equal to 0. So you just go to your calculator. It's a t-test. Remember, section 11.2 turns out to be a t-test of the difference of this. So I put it in L1. I go to stat, t-test. Don't forget, it's a t-test. Data, it's always data. Again, 0. I put my data in L1, and I'm testing that the difference is greater than 0. And here you go. T is 1.9, so we just go here now. Let me just show you completed problem. Okay, we're testing the difference between using match pair. Match pair means before and after. It's the same person before and after. Dependent samples. Okay, that's what I put here. As you notice, guys, the mu d greater than 0. The p-value is... Oh, I got different answers because the numbers were... we got different numbers here. It's 4240 now. Once I say show completed problem, it gave me different numbers. So here 42 minus 40, it's going to be a 2. 43 minus 32, it's going to be a 2. But I'm using the data from the previous problem. So you just put them and you do this. You get the p-value, you put it there. This is bigger than alpha. You fail to reject the null hypothesis, and you say there is not enough evidence to support the claim. Last one. All right. An automobile collision insurance is used to pay for any claims made against the driver in the event of an accident. This type of insurance will typically pay for repairing assets of your vehicle damaged. A random sample of 40 collision claims of 20 to 24-year-old drivers result in the mean of 4540 with a standard deviation of 2291. Another independent sample. So independent, that means you don't use the difference here. You just go to sample t-test. An independent sample of 40 collision claims of 30 to 59 years old driver result in a mean of 3660 and a standard deviation of 2036. using the concept of hypothesis testing, determine if higher insurance premium should be paid by 20 to 24 years old drivers. Test the claim at 0.05, one level of significance. So guys, you need to check if mu1 is greater than mu2, and you can see it's right there. Now, how do you run the calculator here? Stat tests, 2 sample t-test. Not data, I have summary here. I don't have the actual data set. And x1 bar is 4540. It looks like the insurance is paying more here. 2291. And I have 40. And x2 bar is what? 3660. S2 is 2036. N2 is again another 40, I believe. Yeah. And we need to test that mu1 is greater than mu2. Leave oops, sorry. I'll go back. Pooled is no by default, and hit calculate. And here you go. P-value is 0.037. You can see, guys, it's 0.037. What's alpha here? 0.01. So 0.037 is bigger than 0.01. So fail to reject the null hypothesis. There is not enough evidence to support the claim. In summary, if the claim is in H1 and you reject the null hypothesis, you say there is enough evidence to support the claim. If your p-value is more than alpha and you fail to reject the null hypothesis, say there is not enough evidence to support the claim. That ends the study guide.